Well, there are two things that you guys always love to hear about. One of those is anything to do with Optimus. So I'm Randy Kirk, the Optimus optimist. And the other thing that you guys are clamoring for at all times is that Scott Walter and John Gibbs show up to talk about Optimus. So I've done both of those things for you today. How you guys doing?
Howdy, howdy.
Pretty good.
All right. Well, again, this is Randy Kirk, and I want you to like, if you like having these guys here, if you like the subject matter, and then, of course, hitting the subscribe button and notify, and at least two of us. John has a Patreon. Do you have a Patreon yet, Scott? No. Oh, well,
No.
I'm
just a YouTube squatter. You know how that goes. I don't have my own channel.
All right.
I mean, I like your couches. Both of you have really nice couches.
I'm a big Lex Fridman fan. I pretty much listen to everything Lex Fridman does. And so the other day he had a brand new one, and this one happened to be with the CEO of I'm going to forget the name of the
Boston Dynamics.
Boston Dynamics. And it was a fascinating, I'll put the link in the information below, but the conversation was absolutely fascinating. And gosh, guys, I felt like it kind of confirmed a few of the things that we were the first to say, but we'll dig into some of that. So what was, let's see, I know a little bit about what Scott thinks, so I'll skip to John first. John, what was your immediate, you don't want to do the immediate?
No, it's fine. I just my immediate reaction to it was, well, I hate, this is a very weird reaction, but my immediate reaction was, I was like, oh, I'm the same age as the CEO because we basically were in grad school at the same time. And so I was like, wow, he's a really old CEO for this company. And so anyway, just kidding. But I think it's the amount of time it's taken, because in the early 90s at the MIT Leg Lab, they were doing pogo stick, bouncing around and balancing itself. And he said that they didn't have what he considered a good full leg stretch walk until 2022. So last year. So, closing in on 30 years from going from being able to balance itself to being able to have a very human looking walk. And if you look at most robots, including Optimus, they have the little knee squatty thing where they just do the little, very slow shuffle and their knees are bent and it's very awkward looking. And that's one of the beautiful things about Atlas in particular, and Spot as well, is the fluidity of their motions is absolutely beautiful. So, but it's just kind of thinking wow, that is a lot of time they have invested to get from point A to point B. So that was my immediate takeaway.
So pulling up on that just for a minute, now that Boston Dynamics has that fluid working bot, how easy or hard do you think it is to transfer that knowledge or that capability to a Tesla robot or to anybody's robot?
Well, I mean, it's proprietary, right? So they're probably not going to be I don't think they're Tesla. They're not all your patents or all our patents are belong to you. But what they were saying was that, he said the first backflip they did, they had to hand code that sucker. They were in there working it out and tweaking numbers by hand every microsecond. And now it's able to do predictive. They can do it much faster because apparently they have a nice API and a nice language to do it, but also it is predictively, and we could see that. Scott and I think at one point did an analysis of that, and you could see Atlas doing its backflip and kind of slipping a little bit and then correcting for itself, which is clearly a one-off. It wasn't pre-programmed to do that, and that's impressive. The ability for it to on the fly correct any type of trajectory errors.
That was certainly one of the big takeaways for me. Scott, what do you think? Is this any of that transferable? I mean, I'm not talking about the patents, of course, although you could.
No, in some ways, I'm not sure. Trying to understand how they're training it, because it's actuated so much differently. It just seems like the input and output parameters are so much different. It's not like you could just take that network and the weights and just bring them on over. What it does, it shows that it can be done. So it kind of is like a morale boost for everyone else. Like, hey, look, we know there is a solution. Maybe we should be able to do it, or maybe we have to understand why they're able to do it and why we're having such difficulty. What was interesting for me about it is to understand the entire history of the company, because I'd known little bits of it, but I wasn't sure. And so I was able to fill in the picture for me for me to understand what they were doing, what their objectives are. And sort of the realization that everyone seems to thinking that they're like this head-to-head competition between Atlas and Tesla Bot and Boston Dynamics and Tesla, and they're not. They're really working completely different spaces. They're really not competing. I think they're more collegial than anything else. So we shouldn't really see it that way. And the other is, the understanding of how Boston Dynamics is trying to transition from being what was really started out as an R&D company. So the first 10 years, they were sort of playing around with these legged vehicles and everything else, and not really coming up with a product and just learning about it. And then finally, I think it was like the DARPA challenge came along, and they needed a human platform. And I forgot about this part, is that they actually provided like 10 Atli or Atlases, however we would say it, to the different groups. So, they were just really providing the hardware, and everyone else was trying to put the software on top of that. And it was almost from there that they accidentally fell into, say, more of the humanoid form, because they were really looking at applications for legged vehicles and weren't quite sure, but we're not in a rush to commoditize anything, because that's the problem. When you get kind of the R&D mindset, it's a little bit hard to make that transition out. And they slowly get pulled out by Google to move in that direction to try to do something with Spot. But they've, in many situations, it's more or less like they've kind of found a solution, and now they're trying to look for the problem rather than being the other way around. And now they've been able to see that. They're becoming a bit better at that. So at first they got Spot and like, oh, good gosh, what can we do for it? And finally some people said, oh, this is what we've been looking for. And now can you commercialize it and do it? So they have a very niche application for it that, while it's in an industrial setting, it's not the classical industrial setting. Everyone's thinking it's like, oh, they're in a factory, so they must be making things. Like, no, they're not making anything. What they're doing is they're supervising. They're going around, they're making sure the factory keeps running without breaking down, and being able to do the preventive maintenance and a lot of these other things. So it is an area that's absolutely ripe for being able to be automated in a way, and to be able to go into these very dangerous and hazardous environments as well with it. So they found a niche there, but their overall sizes are very small. And then it almost seems like Atlas is, I wouldn't necessarily call it this pet project, but something they're developing, because it's not clear to me that they are looking to sell a large number of these, if they even have, outside of it. So they sold Spot, that's for sure. And I think he mentioned they have 1,100 of them actually sold to customers right now. Was that clear that those were all Spots, or could those have been? Yeah, they were pretty much all Spots, and they want to go to 100. And then they have the other where they looked at the two robots that were going to be doing handling of boxes. Yeah. And so they had both, I think one of them was called Handle and Stretch. Okay.
Stretch, yeah.
So Stretch is the one to have out there. Handle was the first one. And Handle, I thought, was a nice design when I first saw it, because it was like what everyone keeps on saying. It's like, oh, you don't need a legged robot. You can just put a robot on the wheels and go around. And it was just beautiful, like a robot arm on there and everything else. But there was like one thing I said, it's as fast as it looks at everything else, it's probably not going to quite do the application they want because of the speed. And he said it didn't work because of the issues with the speed. And the issue was that it's really handling one box at a time.
Right.
In order to get the speeds that you typically need for that. And it was probably having to move around too much. So in some ways it didn't quite fit for the volume that's going there. So I wasn't surprised. It was just kind of disappointing that, darn it, they needed it. But then they found the other one, which is like the unloading of boxes coming from containers and stuff like that. Because normally, I mean, I guess in some cases, this must be when things are being shipped over from China, because typically you put things in the back of a truck or a lorry, for those who are the other side of the Atlantic, with a forklift. So it's on a pallet and you just drive it in, drive it out, and there's no problem. And then once it's out, then you start unloading it. But they're showing the application. It's like, we've got this container and it's just like stuff full of boxes. The only way to get them out is somebody's just got to go in there and grab them one at a time and pull it out. So they came
I'll tell you,
like my very traditional arm. Yeah.
My one son worked at Kohl's for a while, and the 5 o'clock in the morning call, and it literally was a truck just full of boxes, all random shapes and sizes. So I think it's I think he did mention depalletizing, but also I think a lot of times but it's a really interesting shape, right? Because it's just a big battery which weights it really heavily at the bottom. I think he said 16 hours, right? 2 shifts. battery
it
power.
should be able to do it. And it's a
and
very
then just a
traditional
big-
looking arm. Yeah.
Right. And then a big arm that's off the top of it that can go.
Right.
It's
And that works
efficient
pretty
what they're
well.
trying to do.
And what you're seeing is like, if you're a company that's building that's manufacturing a product, it's the same product, it's the same size. You just put them on these pallets and you can put them in there and you can ship them out there. But when they get somewhere else to a distribution point, you're then going to someone else. And like in this case, it might be Kohl's, where they don't need 1,000 of the same thing. They need all these different products and they all come in different sizes and stuff like that. And the question is, you just take them and shove them in boxes in the back, or in some cases they have what they call mixed palletizing, where they're still trying to figure out how to take boxes of different sizes. And it becomes like Tetris in a way. It's like you're looking over all these different size boxes. What's the best way to actually stack these things up so I get the best control of the volume and I can go in there with a forklift? But it may be that the things are just so chaotic and so different. The solution is you just keep throwing boxes in there, and now someone has to manually put them in and manually take them out. And so they're doing that, and they're saying the orders they're getting is like, not like they want to order one robot, but they all want to order like 10 or 20. So if you get a business model there, which I think that will also scale to about 1,000, but it's not a humanoid robot. It's a very different solution. It's much closer to the traditional industrial robot solution that they have, except it's a more mobile robot. And it's what everyone's just been saying. Do you need to have legs all the time? It's like, no, you don't need to have legs all the time. Sometimes that solution will work.
I want to cycle back to something Scott said a while ago, but I think it's a really important distinction. You were talking about neural nets and things like that. My understanding of Atlas, and probably most of their robots, but let's just talk about Atlas because it compares well to Optimus. That's the humanoid one. As far as I know, that would be what I would call traditional programming. I believe they have a really efficient simulator and a really efficient code base, but it is all if then, loop, whatever. It's that kind of stuff. Optimus is completely based on neural networks and the full self-driving vision system. So they could not be more different, as far as I understand it, in terms of their code bases. So they're not really ultimately competing against each other. Optimus is designed to do something different than what Atlas or Spot or Stretch or any of those things. And by the way, I do think Handle is one of those beautiful. That's the one that looks like an ostrich, which has the big butt that swings back and forth to like counterbalance. I think it's an absolutely beautiful looking. Boston Dynamics has created the best looking motion of any robot I've seen by far.
Because they understand dynamics, and that's the whole thing. Is they've been building these control algorithms for dynamic systems for a long time, which is why it's been a good fit. But it was rather interesting towards the end of the discussion about AI and everything. It doesn't sound like they're 100% committed in that space. It's almost like, well, we're building the hardware and the dynamics and the control systems, and that other part, that's kind of going to be someone else's. We're probably, that's not quite sure whether we're going to bring it in-house or what they're going to do. So to me there, it's like, well, that was a definite difference that you could see right there between the approach that Tesla's taking, what they're taking. But they are very focused on it. And I agree with you, John, because I was trying to figure out what they were doing. And I think he sort of confirmed what you've been thinking as well. It's mostly heuristic, but they may now be starting to put some what was it called? Some learning algorithms on top to improve it, because he said they suddenly went from they couldn't quite get it right to now it works. And the way he described it made complete sense to me, is that they were talking about these different systems they had where something would be typically very dominant in one particular size and everything else was not really that important on the scale of everything. So if that thing moved, it didn't affect the motion of anything else. But he was talking about that, well, the human body, we have a pretty big torso, we get pretty big legs. And, if you move one, it really has an effect on the other from the dynamic standpoint. And also with the legs, it's like, when you swing the legs, you get the reaction that's coming on and everything else. It's like, exactly. And that's been the problem with heuristics, is the only way to solve the whole problem is you break it down into a left leg, a right leg, a torso, a left arm, a right arm. And you kind of solve those independently, and then you try to put them together. And when you do that, that's where you lose the fluidity. And so you need to have something where the whole system, I keep on saying, it's not, you're not solving a 6-axis problem plus another 6-axis problem. You're solving 28 actuators at the same time. And it's very hard to do that heuristically. When you start bringing in the machine learning algorithms, suddenly the emergent property comes out that everything figures out how to optimize itself. And now suddenly your walking gait looks natural. So I was not surprised. And that kind of told me, it's like, it's because they've finally taken a very different approach on how that control system is going to work and figuring out what the layers of that onion are going to be. So there may be some lower layers which are still very heuristic. And then at some point, they're putting something else in there, which is trying to more of a planning phase.
Right.
Well,
You also heard that.
And then when we get to the backflips, I've got a point on that, but I'll
well, but you also heard them talking about it's beginning to have an understanding, a vision system. Now,
Right.
it doesn't sound like it's nearly as sophisticated as Tesla's, but he did say, like Spot, for example, it could go and identify the breaker, like that high voltage breaker that had to be tripped, and like push the button and trip the breaker itself without having to be explicitly told every single step. It's
So
like,
John,
and door handles too.
but
He said you could identify a door handle.
John,
Right.
John, walk through that though just a little bit more, because again, walk
Right.
through what he said it could do, and so
Right.
that we can understand how important that is, because it really speaks to what we've been talking about in terms of putting a robot into a factory and then
Right.
actually teaching it to do steps of a process.
yeah. So, I mean, I think what Scott said, the door handle example might be more obvious because people know what a door handle is. They might not know what an industrial breaker is. So anyway, so Spot is, or what, I guess they were using Spot. So anyway, it's the four-legged thing. It looks like a dog, and it's got this crazy like thing on its, which is like a hand on its head in place of its head. So imagine a dog with a mouth, if you want to think about that. And it's got a very, adjustable mouth, and so it can grab things. And so basically the goal is you'll say, hey, go open that door, go inside and grab me a beer. I don't know. Lex was all about the beers in his video. Apparently he likes his beer. But anyway, in order to do that, it has to not only move through the space, that's no big deal, but it also has to go like, what is a door? What is a door handle? How does a door open? Because if I look over here, the door opens towards me and many other doors open away from me. And they did say, Robert Playter, I was just trying to make sure I got his name right, that they do still have to tell it that where the hinges are, whether it opens in or out.
Hinges on the left and it opens out.
Right. And so it does not know that automatically. So it's not that sophisticated yet, but it is able to look around and probably, again, I don't know that it's using neural networks because there's a lot of more primitive, all the stuff before 2012 was all, pre-neural networks. And what they would do is they would just say like, here's a predefined shape. If you see it someplace, that's the door handle. So it doesn't necessarily have to be neural networks. Although what Scott was saying makes more sense, that it would be more fluid that way. But anyway, it's able to identify somehow that door handle and then say, I'm 2.5 meters away from it, and walk up to it and go like, I am now within reach, do this, squeeze it the correct amount so it doesn't crush the door handle, and then rotate it so it can open it up and then pull it towards itself or away from itself or whatever that is. So yeah.
Yeah. So these are the very things that we've been talking about, that if this Optimus robot is going to work in a factory, it has to be able to move through space. It has to be able to not bump into things. It needs to understand that there's some potential human contact. But then when it gets to the job site, there may be 4, 5, 6, 7, 10 steps. It needs to be able to move through those steps. And then to Scott's point a couple of minutes ago, if it picks up a drill motor, it needs to recognize that there's going to be a torque that's going to cause that needs to respond to that torque, or even just.
I think he even mentioned that in the video, right? He said one of the first Atlases, it missed the door or something like that, turned its hand and flipped itself over because it didn't have.
It was expecting it, right? And
yeah.
the other thing he pointed out is something that we've talked about many times, is that once you lift up something, walking suddenly becomes very different. So it's easy to have a walking robot, but as soon as it lifts something up, especially an object that has a certain amount of mass, then it becomes very difficult, because there's like this instantaneous transformation of your center of gravity from where you're used to it being to suddenly being out there. And then you have what's called a moment of inertia, which may make it, easy or hard for it to be able to turn, and it has to understand all those things. And Lex was sort of asking him, and it was kind of hard to tell, through the cross-examination. So like, are you looking at these objects and sort of identifying what they are and kind of making a reasonable guess? Because he talked about, the examples, you go to pick up an object that you think is going to be light, and suddenly it's very heavy, and your reaction, and vice versa. But he did point out that it is very important from the standpoint of the dynamics that they are able to do that, and to understand how to do the correction from a planned trajectory, because they understand the physics very, very well. So it seems to me they've modeled the robot to an extent that they really understand everything that's going on with it and what you have to do to get the motion you want. And then all they have to then be able to do is figure out, if I'm carrying something, how does it change? So it's like one thing I do a backflip, but now I'm going to put a backpack on on me. And then now let's see if I can do the backflip. And that changes things a lot if you really don't know what is there. The one point I wanted to make about the backflip is that earlier we had talked about this. I'm trying to think if we talked about it with you, Randy, or it was just John and me, that that backflip is something they called the sick trick. So when they were showing the behind the scenes and how it was done and all the programs, they just referred to it as a sick trick. And I was just like, wait a minute, these guys have any idea what they're doing? It's actually a name for what that is. It's a forward somersault with a half twist. And I said, you know, they should have got like a diving coach or a gymnastics coach to tell them exactly what it's doing. Well, it turns out they didn't have to, because Robert Playter is a gymnast, you know.
Yes, yes.
He talked about it many times, so he kind of knows what's going on and is able to tell. And he knew exactly that. Oh yeah, it was just a forward somersault with a half trip. You know, he just called it exactly what it was. So he knows it. But there's a little difference from having maybe been a gymnast, and you know, he may have been a pretty good one, and then also being a coach. So I would still encourage them to go out and get a diving coach or gymnastics coach, because they probably have a slightly better eye of being able to say that, oh, you need to do this a little bit different on your takeoff to get that twist, because they understand physics innately. They may understand the physics and the calculations and everything else, right, but they know what you really have to do to get the body to get that kind of motion out there. But that explains why they're able to do it, is they didn't really have to go outside. They had someone inside that not only knew what it was called and probably how to do it, but he probably could perform. I don't know if he still can perform the trick. That would be the big question. But I'm sure in his day he did it, and it wasn't just like a forward. It was probably like a forward 2.5 or something like that. You know, so.
Yeah. So they also talked about something else that we've been talking about for months, and that was that they have at least apparently 12 robots walking around the offices, gathering data and gathering experience.
Now, I'm not sure how many of those are Atlas. The impression I had is it was spots. So they said they have at least a dozen or so that are always in motion around the office. And they showed it. It seems like there's spots. So again, it's not clear how many Atlas they have doing that, and that they would want to have more. But he did point out that they are looking for applications for Atlas in more of a manufacturing or factory environment. He really said, you know, really between factory and construction. And I think it would be great in construction, because if you think about any construction site, what is the majority of what's going on there?
Dangerous.
It's always material flow. It's always a movement of material. If you think about a roofing project or something like that, the problem is always getting the shingles up on the roof. In the old days, you actually had to carry it up yourself on a ladder. Now there's something to drop it off there. But still, even when it's up there, you've got to move it around. You're constantly having to get up from your work to go get the next shingle you need to put in there. And that maybe if you're lucky, you have an apprentice that goes in constantly as being the gopher to bring these things in. But a lot of construction, it's all about material movement, and taking that away from the skilled tradesman who knows what they're doing, because I got to go over there. I got to, you know, lift this heavy thing up and got to try to fit it to the door. So it could help a lot, and it could save a lot of careers. One of my brothers was a carpenter, and he gave it up, you know, in his 50s, because he just said it was just too much of lifting stuff all day. It was too much on his knees and his back of lifting things around. It wasn't the swinging of the hammer. It wasn't the cutting of the stuff. It was just like having to lift lumber all day and move it over here and move it over there and move it over there. So that, I think, is probably going to be a very good application. And then similar, they're looking for things in the factory, and he made it clear, oh, we don't have hands. We've got to build hands now. And we have to get hands with more dexterity, but not the fine control. He's like, no, we're not putting icy chips, or, you know, you're not going to be putting like the thumb drive into your computer. And he's not that level of dexterity, but enough to be able to do something reasonable within these factory settings. So that's sort of where they're heading. And I guess is what their short-term business model or medium-term business model probably is.
They had talked about, you know, that any particular product that they make, they figured they needed to make about 1,000 a year of them in order to make it a realistic return on investment, realistic
break
profit.
Even, basically.
Break even.
Yes.
In order to justify it. And so as I was listening to that part and the part that you were just talking about as a manufacturer and a marketer, I'm thinking to myself, these guys, they had a transition already where they went from this transition of being an R&D shop to being a shop that needed to make a profit. And he talked about that transition. He talked about his own transition to becoming CEO and how from being an engineer to being CEO. Those were difficult transitions, but I think the transition that they're not even thinking about at this point is the kind of vision that Tesla has of making something that's manufacturable from day one. Something that's flexible enough in its capabilities to be a mass market product. I don't think they're close to that.
Honestly, they seem like they're going a slightly different direction, which is creating specialized products, which could be the reason why they don't know what to do with Atlas, because it's more general purpose.
And it was, they also said at first with Spot, it was kind of generalized, and they hadn't really thought about what kind of sensors to be put on there. Now that they realize the suite of sensors, are like, oh, we should start manufacturing it this way. It'll drive our costs down and everything else. And he said they are learning a lot about how to manufacture now. They have a manufacturing facility. They're learning about injection molding and castings and everything else. So it's a learning curve from them and how to go up there. And they're beginning to understand that they're changing the design and going back and realizing, well, I mean, if the sub-suppliers are already supplying this stuff and now we're telling them to change it again. So they're trying to figure it out. But again, let's say their goals are not that high. If they're just thinking, oh, we want to sell about 1,000 a year, that should be fairly easy to manufacture. It's a very different scale than if you're talking about million or millions per year to be able to do that. So I'd say that they're really looking at some very different level, and they're also looking at a very different cost level. So one of the reasons why Google bought them and then sold them is that Google was thinking, oh, you can take whatever you have and mass produce it, and we can start selling it to like every family in the world overnight. And it's like, no, we can't do that. They didn't know how they would be able to drive the cost down there. And it sounds like they don't even want to approach going on $100,000.
One step further was that, Robert was like, I could tell that there was a huge resistance on their part. They do not want to manufacture something that cheap.
Exactly.
There's like an elegance. They want to make something beautiful. And he mentioned a couple of times like $100,000 plus. And that's not what Tesla is going for. They're not going to build a parkour capable robot. What they are going to do is build one that they can make for $5,000 to $10,000 and then sell it for whatever they can get for it. But that's one thing I just want to mention. One thing that I thought was really cool, which was a nice connection point with Tesla, was the build it fast, break it fast, iterate fast philosophy. Even Robert was like, look, once I figured out I can make the part again myself, that was very freeing. And it's, it's like, oh no, don't break it because you bought this expensive toy. But if you know, like, oh yeah, I built that thing, it'll be annoying as hell because I'll have to build it again. But if you can build it again, there's this enabling capability that you're like, yep, I'll just weld that sucker back together and we'll try again. It allows iteration to happen quickly, which is very cool.
I think the one point he made was that they want to make high quality machines, not cheap machines.
Exactly.
Which is why they were saying we have to be in like the $100,000 area, and that they were looking for industrial solutions. So they've really defined what their market is.
Yeah. And
it's a much smaller market. It's a business to business market. They're not thinking of selling to the consumer.
Right. And I think that's what I'm talking about in terms of this culture shift. They do. He even mentioned it. We have these engineers that act a certain way. They have certain ideas in their head of what it means to be an engineer. And now we're asking them to do completely different things. And the level of things that they're looking for them to do were to be thinking in terms of products instead of just thinking in terms of pure R&D. And it wasn't even on the horizon to think about something that would be scaled up to tens of thousands even, as opposed to thousands.
It feels a little bit like going, since I'm in a university environment, it feels like these guys had this magical, like they just lived in an idealized university where they could just do research for years and years and years and do really cool, sick tricks and stuff. But, I think what's going on right now is Boston Dynamics is like, if we're going to remain a viable business, I think a few years ago, they realized this and they're like, well, we better start selling stuff. All of the challenges change a lot. And suddenly it's like, how do we manufacture these? How do we find markets? What's our addressable market? Like all of those questions change from, can we do this crazy thing that we want to do, to how the hell do we make money with what we have? And that's a very different question.
And in all disruptive things, Tony Stephen talks about this a lot, as does Kathy Wood. is that when you have a disruption taking place, it's usually because there's a convergence. And I was also impressed the entire time I'm listening to this video about the convergence. 15 years ago, you could not have had an Optimus. 5 years ago, you couldn't have had an Optimus. Boston Dynamics has laid the groundwork along with Honda and some others that are coming in a different, all these different directions. But a lot of the groundwork has been laid, and then you get the size reduction on the computer capabilities. You get this convergence of the full self-driving on the cars. You get the convergence of the idea of using vision.
Let's just take the energy density and cost effectiveness of batteries, because their original big dog had a freaking go-kart motor in it.
Yeah.
I mean, that's not scalable. You can't have a go-kart motor robot in, it's like, that's not going to work in your house.
So they were waiting for that convergence of the technology, and so that they could actually entertain the idea of using a battery pack. I think the other thing that was very interesting was, Lex finally asked the question. It's like the elephant in the room. We're just kind of sitting there. It's like, what about Tesla and the Tesla bot? And I thought his response was very much on the mark. That it shows that, like, it's like what we've been saying. It's good. The competition is good. He likes to see the challenge is there, and the result is he said it's suddenly shown a bright light on them that they didn't have before and what they were doing. So it's actually been positive for them that way. And you could also see that it's just been creating more interest overall in humanoid robot forms, and that money is going there. So the idea of doing that has allowed that whole market to kind of open up, because people are saying, oh, look, there's at least two companies there. They seem to be doing something. And of course, he's very proud of the fact that whenever there's a startup out there, they make sure there's at least one person on there that on the resume could say that, they worked at one point for Boston Dynamics.
Right.
So
which I'm sure also happens with Tesla.
The same thing. And there, you will see that in some of the startups that are out there for sure. And that's, and that's a very important thing, because anyone that started that way, I mean, it used to be that way. The Joe Engelberger's first company was Unimation Robots. So that was the first industrial robot manufacturer. And at some point, that's what it was. It's like people kind of went out. They used to refer to it as the robot university, because you went there, you learned about robots, and then you went and worked for someone else, because that's where you got it. So everyone always, you made sure you had like Unimation in your pedigree, and you would get hired somewhere.
Now, so one of the things that we're most famous for, going all the way back to when the book was practically written, was the idea that there needed to be a fleet of robots out there learning. And he confirmed that. He said, any startup, anybody that's going to get in the robot business, he says, whatever, they better have a budget, because they're going to need a fleet of robots to be out there learning. And so I thought that was nice confirmation of the direction that we've been talking.
It is. And this is where I might push back a little bit, because, towards the end, there was a discussion about AI and LLMs and everything. And I agree with him on some of the things on large language models basically being a carny trick that makes everyone think it actually is conscious. It's not. I know John and I have had this discussion back and forth. I'm not quite sure where John is in the camp. It's just that
I don't
really
think
good statistical engine.
I agree with you on that.
Trick a lot of people into thinking it's intelligent, but deep down, it really isn't. So he's got that kind of suspicion. But at the same time, I'm not sure that they have a big enough fleet. So they've got a dozen of the spots walking around, and they're getting like 1,500 to 2,000 kilometers of walking, I think he said, a weekend. So they're getting that in from that, and they're getting a lot of useful data. But it sounds to me like a lot of the data is just like learning. It's like, well, when does it wear out? And, what are some of like these other kind of edge cases, which might be more mechanical in nature as opposed to software in nature. And I think you need a much bigger number than that. So it's one thing to say, we're going to keep on running our product till we see it breaks and find out what the failure point is and re-engineer around that. It's another thing to say we're using it to teach the neural network. So I'm not sure how much they're doing it there. And those Atlas are very expensive. I mean, I don't know what they are, but he was saying, somewhere from 100,000 up to 1 million, so let's say 100,000. That's a lot of money for one. And, I'm sure the first couple Optimi were also on that order. But once they get that down, they'll be able to crank them out for a much cheaper number. And then you get that fleet, because I don't think you can call a fleet a dozen.
No,
I'm
no.
not sure you could even call it 100. When you start to get to 1,000, now you're starting to probably get enough that you're starting to see some interesting data coming in. And then, then if you can scale above that, then things will go a lot faster.
Well, yeah, I think your point earlier was that he talked a lot, well, not a lot, but he went out of his way to talk about how they're learning to die cast things. They're learning to use plastic where they can use plastic. I mean, the first ones, they must have been honed out of out of raw metal.
Yep.
He did. He actually said that they CNC these things out of billets, and they were just learning how to cast. I was like, good gracious, that's an expensive way to go if you're mass producing something. So
yeah. So they should be able to get the cost down. And he did talk a lot about first principles, and how to get the most you can possibly get out of the least. And I'm sure they're moving in that direction. But I think the culture may be impossible to move. And if they get something going, which gives them, I thought very early on, I was saying that I thought one of the biggest things that the Optimus could do would be quality control. I had not thought about checking on gauges and checking on the quality of or the operational capability of equipment, making sure things are being maintained when they should be maintained. But man, that is a really good use for Optimus.
But at the same time, I mean, that kind of surprised me because then they were talking about, someone going around with a clipboard writing things down in a gauge. I was like, haven't they heard of the IIoTs? I mean, that's what I thought the manufacturers are doing, is that you don't really have gauges anymore, or if you do, you have it connected so someone somewhere else is able to look into that stuff and understand it. But it could be that there are certain industries where it's just not practical. That a lot of them might be like refineries and stuff like that. That it just makes more sense. You have to go out there and read directly on there. You can't trust whatever readings you're getting. So there's probably a bigger market for that than I'm aware of. But to me, it was like, okay. But I wonder how long is that going to last when they finally convert over to digital gauges for everything.
Right. But anything like that, anything where it's a visual inspection, and believe me, again, I always think in terms of these smaller businesses. My company only had 100 employees, but if you have the ability to visually inspect things that people are inclined not to, or forget to, or how many times you train them, they don't.
And then again, I guess I should look at it as like, I have an example, a personal example, which I think is kind of silly, is that when I wired the house with solar, the first thing I had was like net metering. So I put a new meter in there, and that was absolutely great because they didn't have to come out and read the meter anymore. But then I said, but I want to have, time of use of the meter. So they had to put another one in there. But that one they can't read at the home office. So every month, I get this thing, make sure your dog is in the house and there's no fences because we're going to come out to read the meter. And I cannot believe it. And they literally come out to read the meter. I mean, when they first had some of these smart meters, they drove by at least. So they came by and from a certain distance, they can do it. Oh, yeah, I guess some industry is going to take forever to ever convert to the 20th century or the 21st century, whatever it is.
Well, printing comes to mind because I was a printer, so I'm printing on bottles, or you could be printing on T-shirts, or printing on one of millions of advertising specialty products where you're printing corporate logos on things. And it's really important to those companies to make sure that logo is correctly on there, that there's no mistake, that it's not oversprayed, or that it's not chipping off, or that it's not, so you have humans, even if they're really good at quality control, tend to become numb to seeing the same thing over and over again, whereas a robot will never become numb. And it's not just in advertising specialty that you have printing. You have lots of other areas where something being printed can now be overseen. And yes, you can buy stationary cameras just like you can buy stationary arms, but a stationary camera is a stationary camera.
And
it has one application. That's all you got.
Especially if you only need it like 5 minutes out of every hour or something like that.
Right. Yes. So lots and lots of applications in that direction. So so their theory is that they want to build 1,000 at a time, 1,000 a year, some of these specialized robots, put them in. I think that's sounds to me like a fine business plan, at least for the foreseeable future, maybe 3, 4, 5 years. I think there's a point at which but they may be able to 3 or 5 years from now begin to become a little more flexible in
they're diversifying a little bit. So looking at the box handling solutions they're doing, it means they're getting into the more traditional robot arm manufacturer, integrator kind of thing. And they're going to be learning a lot about that. And when they start doing it now, all their customers are going to be showing them these other applications, and they'll say, oh, could Spot do this over here? Or can you? So it may be one of those things that they end up getting bigger scale, bigger than they expect. So they might be thinking, oh, we'll be happy to be in this niche market. And then one day they might just come to a tipping point and suddenly realize, wow, we have something here. And I'm kind of looking at it that way, that I think they're setting their sights low with the hope that, maybe it just sort of takes off. But
I think, Scott, what you're saying actually puts me in mind of, so they developed Spot originally, of course, is just the platform. It's just basically a table with legs that move, more or less. And then he said when they put the arm on it, it's a whole separate robot. And it's actually, you can put it on a version of Spot that didn't even have that capability in mind, right? So you can retrofit the thing. And then the same thing you see with Stretch is basically it's a bigger version of that arm, but it's the same thing. So it is possible that in the end, Boston Dynamics may become an arm robot company, that they just manufacture these big arms that you stick, because like you were saying, you don't really need a mobile robot to check the quality of the print of a bottle as it's going down a line, but maybe having the arm and the ability to pull it off if it's not good and throw it in a bin. That's pretty cool. I mean, that takes the place of two workers, one who's checking and one who's pulling. So, yeah.
But I think, I'm not sure that they want to be a big arm robot manufacturer, because he did mention towards the end the importance of two arms. So that, and the reason why you have two arms is that when you pick up something, you can easily reposition it with the other. And if you have one arm, it's very difficult to do it. So there's certain advantages to doing that. And they're being able to understand the interplay of the two, so, which is kind of ironic to see that, they've got a couple of one-armed robots moving around, they're doing this, but it's good learning experience to understand what the industrial applications are and why they see those as being a good fit and what you could potentially do to change that in the future.
And that was another thing that I think we got right, at least from Boston Dynamics' point of view, is we were saying, hey, they're going, when they start putting this into, whether it's their subs, their manufacturing partners, or whether they start actually selling it to manufacturers, that they would want specific use cases. They wouldn't want to just sell it to anybody in the early days. They might take applications. Okay, that's a great application. We'd like to try that. And also that once in that particular situation, the interplay between the manufacturer that they sold it to and Tesla would, well, in this case, Boston Dynamics, they're very interested in that interplay and how can we take it further? What can we do that would do more? How can, so that kind of relational kind of push and pull, I think will be really, really important for Optimus. But I think we talked about that in great detail in one of our videos. Yeah. What else? Any other takeaways?
Boston Dynamics has like a place in my heart because they have been doing this for a long time. And I feel like even though they've had a lot to do with the Department of Defense, I appreciated that Robert specifically said that they've signed off on a document that said no weapons on our robots. And you start looking at Atlas and it looks a little bit like it could be like the Terminator exoskeleton with a couple of big guns attached to it. So, so I appreciate that they, have negotiated the best path possible to be a commercial company while still being as research focused as possible. But in terms of being a direct competitor with Tesla, no. I mean, they're looking at scales of 1,000 or maybe 10,000 someday for something. They're not looking at hundreds of thousands to millions a year.
Yeah, you have to go back to their roots. They really were a research and development organization, and that's still kind of in their DNA. And you can see that they already split off like another lab from it, which I think is supposed to be like the Boston Dynamics AI lab.
Right.
And they're really not looking to solve problems or necessarily they're looking very much in the future. They're trying to figure out what are tomorrow's problems, what are the ways that we can start attacking them. And it's almost like they don't really want to be commercializing anything. They just want to get to some state of the art, make some, some publications, show how things are, and then let someone else commercialize it and then move ahead. And that's fine, because if that's sort of their mindset and how they're what they're made of, we need more of that. Someone's gonna. That was the whole idea of the moonshot. There was absolutely no practical application to putting a man on the moon, except all the stuff we needed to get there. Right. So it's the same thing. Is they're developing a lot of these things that are going to be very useful down the road, even if they are not the ones to commercialize it. We will all be, we will receive the benefit from them.
Well, they did talk a little bit about the existential question of robots with guns, and robots as potentially bringing about some really bad situations in the future. I don't know if I've ever said it to you two guys, but I long ago stopped fearing robots with guns, because now we have drones.
Yeah, right.
Drones
That's even scarier. Yeah,
drones with guns are way better than robots with guns.
Well, we're already seeing it's actually not drones with guns; it's drones with hand grenades.
With hand grenades, yes, right, exactly. Or drones with needles.
Yeah, it's a little bit crazy that we've almost headed back to World War I, because that was the original. When they had the first planes, the guys would just take hand grenades and chuck them out. Right. It's like so we're weirdly cycling back to 100+ years ago now.
Yeah. No, I can't think of anything scarier now in a battlefield. I used to think it was the Black Hawk. Is if I was ever in a battlefield and a Black Hawk came over the hill, I would be like, oh my gosh, I would probably die immediately. They wouldn't have to shoot me. Right. Now, can you imagine a swarm of drones coming over the hillside? It's just unbelievable to contemplate. Anyway, all right. So, so I thought it was, I'm just going to recommend to everybody listening that they go take a look at this video. If you're slightly interested, it was it's a Lex Fridman video. What are we going to talk? It did not seem as long as it was. It was very interesting. So I definitely got the entertainment value out of it and the interest. It kept me going. It was engaging.
Yeah.
All right. Well, thank you guys for coming on again. And for those of you out there, please like and subscribe and go over to John's channel and go over to Scott's channel and watch their videos too, because they both do. Actually, John is way ahead of me. He's got way more subscribers. So subscribe to me.
Randy's catching up quick.
I'm trying. I'm heading for 10,000. You're heading for 60,000. I'm heading for 10. It's okay. All right. So, and then of course we both have that Patreon site. So take a look at that. Everything down in the description below. And again, thank you guys for showing up. And for you out there, it's been great talking to you.
Click the link below to get your paperback, Kindle, or audiobook now.